So we have our first sample question. Going right into the sample question, multiply and simplify. Again, we have our four corners. So what we're going to do is factor out each of the four corners. Remember, when you factor out each of the four corners, because we're dealing with rational expressions, we're going to be looking for GCFs and then count the number of terms. So each of these corners, we're going to do that. So the first corner, notice it's 3a minus 21. Hopefully you see that there is a GCF. It has two terms, but notice, if you remember, 21 is 3 times 7, so they both have a 3 in common. If we talked about GCF, just in case you forgot, remember you're secretly going through A through D. Do you have matching parentheses? Do you have the same letter in each term? Do you have the same number factor in each term? And do you have a negative starting? And you can see that the only thing that I have here is that they both have a 3 in common. So when you take out a 3, then my leftovers would be a minus 7. Then count the number of terms left over. Notice it's two terms. When you have two terms, you look for difference of squares. Because this doesn't have a square, or to the 4th power, or to the 6th power, it doesn't have an even exponent, I cannot factor this any further. Moving on to the next corner. Notice it's just a monomial. How do we break down any monomials? You would try to do it as a tree diagram. There's no number in front, and notice that there's no exponent, so that just means that there's one a. So you're done with corner number 2. Corner number 3, again, always look for a GCF first. So notice that they both have the same letter. Right? Doesn't have to have the same amount, just the same letter. So we know if we can take out a GCF of A, YA, because 2 versus 1, you always take out the smallest amount. And if I take out 1A here, I'm left with 1A. And if I take out the 1A here, I'll still be left with the plus 4. Once you factor out the GCF, then see if you have difference of squares, because this is a binomial. Notice, yeah, that's a perfect square, but A is not. It has to have a square here. It also had to have a minus sign as well. So you can't even factor that any further. And then the bottom corner, again, always look to see if there's a GCF first. Yes, they're both even numbers, so you know that there's a hidden 2, because 14 is 2 times 7. So we're going to take out a 2. Then you're left with A minus 7. Remember, when I take out a 2, I'm just basically dividing each one by 2. So what's left over would be 1A, or just A, and then 14 divided by 2 is 7 with the negative. And then I can't factor this any further because, again, that's not a perfect square. Once you factor out each of the 4 corners, okay, we look for GCF, and then we count the number of terms and see if we could have done them as difference of squares for a lot of them, or tree diagram. And then you're going to draw your big fraction bar. So, big super fraction bar. That way, we just have a top and a bottom, not 4 corners. And then we're just going to cancel out matching factors. Now, you can, again, never cancel out a monomial A with a binomial A. I know some of you saying, well, there's an A on top and an A on the bottom. Binomials can only cancel out with other binomials. Okay, so always do that. Matching parentheses are usually the easiest ones to find first. Once you cancel out the A minus 7 on top with the A minus 7 on the bottom, then see if you have any monomials. So remember, you can have matching binomials, so you can cancel that out first, and then matching monomials. So notice this and this. They're both monomials. You can cancel out A with A. Notice nothing else matches. 3 and 2 don't match. There's no binomial A plus 4. I don't want you to say monomial 2 can go into binomial 4. That's a no-no. Binomials are separate from monomials. So what's left over is this, and this. So our leftovers is going to make our reduced fraction. Now, some people might multiply this out, which is fine. 3 times A is 3A, and 3 times 4 is 12. But I prefer just to say I have a leftover 3, and I have a leftover a plus 4, and then what's left over at the bottom? 2. So I think this is perfectly fine as an answer, but some people prefer to distribute this out to give you 3a plus 12 over 2. But to be honest, I always like it in this method, because I know someone's going to say, well, 2 can go into 12, and I don't want you to do that, because this is not a monomial. It's part of this binomial. See how there's 2 terms? So you can't do the 2 is to 12. So I would prefer you to keep it like this, but if Alex, the computer system, you see an answer like this, it's just because they distribute. But this is fine.